Okay, so lesson 2.8 is really similar to lesson 2.7, so I'm kind of combining them into one lesson. So I've got the vocabulary written out. I'm going to read through them and kind of explain. A scale. If you've ever seen a map has a scale. 1 inch is 100 miles or something like that. So a scale is a ratio of one length to another. So it helps you scale something. Usually with scales, you use a model, and those models use similar figures. So similar figures are figures with the same shape, but not the same size. So if you have the distance between Green Bay and Milwaukee on a map, that distance is going to be similar in proportion to the distance, the actual distance between Green Bay and Milwaukee. So similar figures are figures with the same shape, but not the same size. A scale drawing, a map is a scale drawing. It's a 2D drawing comparing similar figures or similar lengths, proportional lengths. Okay. A scale model, if you've ever seen a model of a home, a smaller model of a home, it's a 3D model similar to a 3D shape. Usually use models to kind of see how the dimensions of a house would be, but obviously you can't build the whole house. So scale models are 3D. Scale drawings are 2D. So an example of similar figures is these two triangles. These two triangles are the same shape, but not the same size. So if we're comparing sides, okay, AB is similar to DE. BC is similar to EF. A to C is similar to D to F. So if we're trying to figure out these lengths, figuring out what DE is. DE, let's just use X for DE. Let's use Y for AC, okay? DE is proportional to AB. So that means X is proportional to 10, okay? And then from that same triangle, 12 EF is proportional to 16 BC. So I could write this as 12 over 16. And you got to notice that 12 and X are on the same shape, so they're both on the top. 10 and 16 are from the same shape, so they're both on the bottom. So this is just like the previous notes. Cross multiply 16x, cross multiply equals 120. Then I can divide by 16 on both sides. So x is 7.5. And it should make sense that it's smaller, right? It should make sense that it's smaller. So to find, so I would say here, let's say DE is 7.5. That length is 7.5. For AC, I'm going to use the variable y. Y is proportional to 18. They're both the bottom, okay? And then I use the same proportion as before, but I got to know, since y and 16 are on the same shape, I'm going to use 16 to 12. Okay? So since y and 16 are on the same shape, they're both on the top. So it's just using that same proportion or ratio as before, but flipping it because y and 16 are on the same shape. So this would be 12y equals 18 times 16. Okay? I'll use my calculator for that because I don't want to fudge the mental math on that. 18 times 16. That's 288. And then I divide that by 12. Y is 24. So that means AC is 24. So you write the ratio comparing sides that match up in different shapes. Okay? So setting up that ratio, we're going to get some practice with that a little bit later. Next, applying similarity in a diagram or a scale drawing. It says the sun rays strike the building and the girl at the same angle, forming two similar triangles. How tall is the building? So you can maybe see the X there for how tall the building is. So that's the height. So the height of the building, X, is going to be proportional to the height of the girl 5. So then the other ratio I set up is the distance from the distance of the building shadow to the girl's shadow. So building shadow is 15, girl's shadow is 3. So the two lengths associated with the girl are on the bottom, the two lengths associated with the building are on the top. So I would cross multiply, 3x equals 5 times 15 is 75. And then I divide both sides by 3. X is 25, and it's 25 feet. And that kind of makes sense because the shadow is 5 times the girl's shadow, so the height should be 5 times the girl's height. So logically that kind of makes sense. They're proportional in that way. So here I know maps aren't a very common thing anymore, but it's still nice to be able to read a map and figure out what's going on with that map. So this says, what is the actual distance from Jacksonville to Orlando? We're going to use the ruler to measure, and then we're going to set up our proportion. Okay, so our scale on the map, I'll move this down a little bit. We can see it's 1 inch is 110 miles. And it says the distance from Jacksonville to Gainesville is about 0.6 inches. So we got to find the actual distance. So we're going to do the ratio of the map distance to the actual distance. So the map distance is 1 inch for every 110 real miles. So we measured 0.6 inches on the map, and we don't know how many actual miles. So let's use m for miles. So I set up that ratio. The top represents the map length, distance. The bottom represents the actual distance. So this would be 1m, or just m is fine, equals 110 times 0.6, which is 66. So that would be 66 miles. So the scale, that's the ratio we're given. We set up that ratio. We make sure inches stay on the top, miles stay on the bottom. So in this next example, I think it would be a good idea for you to pause the video and try this one on your own to set it up using the map at the top there, and then we can work through it together. Okay? So I'll give you guys a chance to work through that, and then I'll show you my answer after a few seconds. Okay, so for this one, it's a little less about the proportion, and it's a little more about understanding the ratio, okay? So it says if you know the actual distance between two cities is 250 miles, and you measure they're 2 inches apart on the map, maybe the scale on the map was like ripped off, or there's a stain on it and you can't read it. So how can you find the scale of the map that way? You know the ratio of map distance to real distance, so as a fraction, you could just say, divide them both by 2. That means every 1 inch represents 125 real miles. So it's all ratios, fractions. So that one is more about understanding the ratio side of things, okay? And then finally here, applying similarity to a model of a heart. It says a giant model of a heart is shown below. The heart is the ideal size for a person who is 170 feet tall. About what size would you expect the heart of a man who is 6 feet tall to be? Now, that's kind of a goofy way of saying it, because there's no human being that's 170 feet tall. But if your heart was 14 feet tall, you would be 170 feet tall. That's what it's saying. Okay? So, when we figure this out, what would be the heart of a normal sized man? Well, let's set up our proportion. Let's have X be the heart of a normal, realistic human as the ratio of the human's actual height. Okay? So X and 6. This is the normal size. And then the ratio for the Mr. Giant here, or Mrs. Giant, would be 14 to 170. So if your heart was 14 feet tall, you'd be 170 feet tall, if this is all proportional. So I would multiply across. This would be 170x equals 14 times 6, which is 84. Okay, so I would divide both sides by 170. X is going to be roughly, it's about 0.49. Let's just say 0.49 feet. Okay, so 0.49 feet. That's around 6 inches, pretty close to 6 inches, but almost half a foot, so around 6 inches. So if you're 6 feet tall, your heart is about 6 inches, 6 inches tall, or 6 inches, from bottom to top. So proportional reasoning. The big model is so that you can see the parts of the heart a lot easier. A 6-inch heart it'd be hard to see all the valves and everything else. So we make models to sometimes make something bigger so it can be easier to look at. And then it's just knowing that that's proportional. So setting up that proportion, actual height to actual heart to giant height to actual heart. So being able to set up that proportion is important. So I'm going to have you move on to the next step in the lesson, which was most likely going to be the practice. And I'm going to have you work through that. This combines practice from the previous notes and these notes. So it's going to have 2 different practices, but 1 single checkpoint. So I'm going to try and make the practice manageable, not too long. And just make sure that you're emailing me and flagging me down with questions, okay? So I'll have you move on to the next step in the lesson.